The night sky looks crowded. It is not, really. It only looks that way because the dark is so patient. Above the roof, past the last of the streetlights, there are more stars than a person could count in a lifetime of clear nights. A few 100 billion of them, just in our own galaxy. And around a great many of those stars, quietly, there are worlds. More than 6,000 of those worlds have been found so far. Real places, measured and named by careful people. Yet after all of that finding, after more than 60 years of listening, the sky has stayed quiet. Nobody has ever called back. So the question tonight is a gentle one. If the universe is this wide and this old and this full of room, then where is everybody? Nobody knows for sure. There are real reasons it might be so quiet, though, and a few of them are almost kind. We are going to drift through them, one at a time, with the lights low. This is a place for tired minds and long nights. It is for anyone who likes to fall asleep somewhere enormous and calm. If nights like this are your sort of thing, a quiet subscribe helps other people find them, and there is no pressure at all. Tell me where you are listening from, if you feel like it, and if you ever want the wide-awake version of this same wonder, the daytime channel Cosmic Tide covers it. There is nothing here to stay awake for. If sleep arrives before the second chapter, that is the video doing its job exactly right. The plan for the night is a simple one. We begin with the question itself. Then we go looking, one calm place at a time, at everything that makes the silence surprising, and everything that makes it easy to rest inside. The question is older than it feels, and it started somewhere very ordinary. It started with a walk to lunch. In the summer of 1950, a physicist named Enrico Fermi was crossing the grounds of a laboratory in the New Mexico desert. His friends were with him. They walked toward the lodge where everyone ate, the way Fermi, that is Fermi, liked to walk, thinking out loud about something and nothing. The talk had turned to flying saucers, which were in all the papers that year. Then it drifted to other things, the way lunchtime talk does. They sat down. The subject had moved on. And then, out of a small silence, Fermi asked the table a question that had nothing to do with anything. He said, more or less, well, where is everybody? Everyone laughed. The strange part is that everyone also knew exactly what he meant. He meant the aliens. He meant that the galaxy is unimaginably old and unimaginably large, and that even a slow and patient civilization would have had time to spread across it many times over. He had done the rough sums in his head between the door and the table, and the sums did not match the sky. The sky was empty. That small lunchtime question grew, over the years, into one of the quietest and most stubborn puzzles in all of science. People gave it a name. They call it the Fermi paradox, though it is less a paradox than an honest itch. The universe looks like a place that should be full of life. So far, it has stayed silent. Those two facts sit next to each other and refuse to shake hands. It helps to feel how much room the puzzle is really about. Our galaxy holds a few 100 billion stars. If a person tried to count them, one each second, without sleeping or stopping, they would still be counting long after the sun had burned out. and our galaxy is only one. There are hundreds of billions more, scattered out into the dark like distant towns. Fermi was not frightened by any of this, and there is no reason to be tonight. He was curious, in the pleasant way a person is curious about a locked room in an old house. The light in the lodge was ordinary. The coffee was ordinary. A man simply looked up from his lunch and wondered where the neighbors were. We have been wondering ever since, and the wondering has been good company. So that is where the night begins. Not with an answer, but with a very old and very human shrug at a crowded, silent sky. The neighbors have not written. We are going to spend a couple of hours being fond of the mystery, rather than troubled by it. It is worth sitting a moment with how strange the silence really is, because the strangeness is the whole reason anyone still cares. Picture how a single patient people might fill a galaxy, even a slow one, even one no cleverer than us. They send out a few ships. They settle a world or two. They wait a while, get comfortable, and send out a few more. Do that over and over, at a crawl, and the sums are startling. A slow wave of settlement, dawdling along, would still wash across the whole galaxy in a few million years. And a few million years, set against a galaxy more than 10,000 million years old, is nothing at all. It is the last hour of a very long year. So time is not the problem. The galaxy has had more than enough of it. If even one curious species had woken early and felt like wandering, their traces could be spread everywhere by now. Old ships parked in quiet orbits, old radio still washing past, some mark somewhere that others had come and gone. By the plain logic of it, the sky ought to look busy. Instead, it reads as still and empty, and that stillness is the puzzle in a single word. Fermi turned all of this over on the short stroll to lunch, without a chalkboard, the way some people hum without noticing. Plenty of stars, plenty of time, plenty of room to spread out, and yet not one solid sign of anybody. The books did not balance. The universe looked generous and behaved like an empty house. None of that frightened him, and it need not frighten anyone tonight. The flying saucer stories filling the papers that summer were almost certainly nothing at all. A silence is not a threat. It is only a puzzle, and a soft one, the kind a person can turn over slowly in the dark and never need to finish. It is the kind of puzzle that grows richer the longer a person holds it, rather than wearing thin. Every year the telescopes find more worlds, and each new one sharpens the question instead of settling it. The more crowded the sky turns out to be, the louder its quiet becomes. Most puzzles shrink as the facts arrive. This one only swells, and it reaches as far as anyone cares to look. The same stillness hangs over the nearest stars and over galaxies so distant that their light set out before the Earth had formed. Wherever we point, the pattern holds. Room enough for a great crowd, and no clear sign of one. A person could find that eerie if they wished. It seems just as fair to find it restful, the way a still lake at dawn is restful, wide and quiet and asking nothing of anyone. So the puzzle is a safe thing to carry down into sleep. It will not be solved tonight, or this year, or perhaps within any of our lives, and that is no fault in it. A good question makes pleasant company for exactly that reason. It never runs out, and it never demands. There is even a small joke folded inside it. We are the aliens, seen from anywhere else. If some far-off astronomer is doing their own sums over their own quiet lunch, then we are the neighbors who never wrote to them either. The silence, if that is what it is, runs both ways. The question, for now, can just sit with us in the dark, patient as the stars are patient. The best way into a puzzle like this is to start with the numbers, gently, because the numbers are where the surprise lives. Begin with a single galaxy, ours. The Milky Way holds somewhere between 100 billion and 400 billion stars. Nobody can give a tidier figure than that, which is its own kind of wonderful. We live inside the thing we are trying to count, and from in here the edges are hard to see. 100 billion is a number that slides right off the mind, so it helps to make it small. If every star in our galaxy were a grain of sand, they would just about fill a small room, floor to ceiling. And every single grain would be a sun. Many of them burn warmer and steadier than ours. For a long time, nobody knew whether those suns had planets. They might all have been bare. That worry is now over, starting in the 1990s. And then faster and faster, astronomers began finding worlds around other stars. They found them by watching for tiny dips in starlight, the shadow of a planet crossing its sun. They found them by measuring the little wobble a planet's gravity gives its star. The count now stands above 6,000 confirmed worlds, and it climbs almost every week. 6,000 in about 30 years of looking. That is roughly one new world every couple of days, quietly added to the list, while the rest of us are busy with ordinary things. The bigger lesson is hidden in that number. Planets are not rare. The best estimates now suggest that most stars have at least one, which means the galaxy is not a scatter of lonely suns. It is a place with billions upon billions of worlds. Rocky ones, watery ones perhaps. Worlds with weather and seasons and long, quiet mornings. And then, past the edge of our galaxy, the whole thing repeats. Hundreds of billions of other galaxies, each with its own vast crowd of stars, each with its own uncountable worlds. The numbers stop meaning anything after a while. They just become a feeling. The feeling of standing in a doorway and seeing that the house goes on much further than expected. This is the half of the puzzle that makes the silence loud. With that many doors, a person expects at least one of them to open. That is the weight Fermi felt over his lunch. Not fear, just the plain arithmetic of a very large place. The way those worlds are found is worth a gentle word, because it is cleverer than it sounds, and it asks nothing of the listener but a slow nod. Most of them were caught by shadow. A telescope stares at a star steadily for a long time and waits. If a planet happens to cross in front, the star dims by the smallest sliver, then brightens again. One space telescope, called Kepler, did nothing but this for years. It fixed its gaze on a single patch of sky, on more than 100,000 stars at once and simply watched for those tiny, faithful dips. Thousands of worlds turned up in that one patient stare. A newer telescope has since taken up the watch across almost the whole sky, hunting those same small, faithful dips. The other trick is to watch the star sway. A planet tugs on its sun as it goes around, and that tug shifts the star's light by a hair, toward the red as it pulls away, toward the blue as it swings back. From that little rocking, astronomers can weigh a world they cannot even see, without ever catching a single glimpse of it. And what a strange list it is. There are giant worlds bigger than Jupiter that huddle so close to their stars, their year is only days long, roasting and fast. There are worlds larger than Earth but solid underfoot, the ones with no cousin in our own family. There are planets that circle two suns at once, so that a sunset there would be double, one star setting behind the other, exactly like the view from a certain famous desert in the films. There are even worlds with no sun at all, cast out long ago, wandering the dark between the stars on their own. The headline hidden in all of it is simple and staggering. On average, very roughly, there is about one planet for every star, which means the number of worlds in our galaxy is not smaller than the number of stars. It is about the same. A few 100 billion suns and a few 100 billion worlds to keep them company, at the least. If every person alive were handed 1,000 of them to survey, we would run clean out of people long before we ran out of worlds. There is one more number worth feeling, and it is made of time rather than space. The universe is about 14 billion years old. Our sun and our Earth are latecomers, formed only in the last third of that long stretch. And we, the wondering part of it, arrived a heartbeat ago. If the whole history of the universe were squeezed into a single year, everything any human being has ever done would fit into the last few seconds before midnight. That matters for the question of company. The galaxy has been making stars and worlds for far longer than the Earth has been around. Countless suns were born, burned, and died before ours was ever lit. Whole planets formed and warmed and cooled and crumbled in ages long before anyone was here to give them names. If life is a thing that simply happens where it can, then it has had an enormous run of time to happen in, over and over, long before our own small morning. So the crowded feeling grows in two directions at once. There are more worlds than anyone can count, spread through more galaxies than anyone can picture, and there has been more time than anyone can hold, age upon age of it, in which any of those worlds might have stirred. The stage is impossibly wide, and the play has been running an impossibly long while. And still the house seems quiet. So the rooms are there, more than anyone can count. The next question is softer and stranger. What would it take for a light to come on in even one of them? There is a story about a chalkboard, and it is one of the nicer stories in science. In the autumn of 1961, a young astronomer named Frank Drake helped gather a small group of people at a radio observatory in the hills of West Virginia. There were only a handful of them: a chemist, a biologist, an engineer, A young Carl Sagan among them. They had come to talk seriously about a question most serious people still avoided. Was it worth listening for other civilizations at all? To give the meeting some shape, Drake stood at a chalkboard and wrote a single line. It was not an answer. It was a way of breaking one impossible question into 7 smaller and more honest ones. That line is now called the Drake equation, and almost every conversation about alien life still leans on it. The idea is calmer than it looks. To guess how many talking, broadcasting civilizations might be out there right now, a person multiplies 7 things together. How many fresh stars are lit in the galaxy each year? How many of them have planets? How many of those planets could hold life? On how many life actually begins? On how many that life grows clever? How many clever species learn to send signals? And, last and gentlest, how long such a civilization tends to last before it goes quiet again. Some of those numbers we now know rather well. The first 2, about stars and planets, have filled in nicely in the years since. Stars are common, planets are common. The front of the equation looks friendly. The trouble is the back of it. Nobody knows how often dead chemistry stirs and becomes alive. We have exactly one example of that happening, and we are standing on it. Nobody knows how often life, once started, ever bothers to become clever. And nobody at all knows the last number, the lifetime, how long a civilization keeps its lights on. The honest range for that final answer runs from a few decades to a great many thousands of years, and the whole result swings wildly depending on which you believe. So the Drake equation does not tell us how many neighbors we have. That was never really its job. It is a tidy way of sorting what we know from what we only hope, and of seeing, at a glance, exactly which of our guesses is doing all the heavy lifting. It turns a shapeless worry into 7 neat drawers, most of them still empty. There is a lovely small moment from that meeting, worth keeping. Partway through, one of the guests, a chemist named Calvin, was handed a telephone message. He had just won the Nobel Prize. They paused and were glad for him, and then went back to the chalkboard and the question of whether anyone else in the universe was doing the same sort of thing on some other quiet afternoon. That is the shape of the search, really. A few thoughtful people in a small room, multiplying their own uncertainty and being kind to each other while they do it. The equation still hangs over the whole field like a familiar old map. It helps to walk along that line of 7, slowly, because each step is really just a plain-spoken question. How many new stars are born each year? That one we know now, and the answer is comfortable. Stars keep being made all the time. How many of those stars have planets? We know that too, and the answer is most of them. So the first 2 doors swing open easily, and the galaxy fills with worlds before the equation has properly begun. Then the ground softens. On how many of those worlds could life get a foothold? A fair number, maybe, going by the seas and temperate zones we keep finding. On how many does life actually begin? Here, nobody can say. Then, of those, how many ever grow clever? And of the clever ones, how many learn to send a signal out into the dark? Each of those numbers is a guess wearing a brave face. And the last one is the softest of all. How long does a talking civilization last before it falls quiet again? A few decades, a few thousand years, longer. Nobody has the faintest idea, and the whole answer swings on it. Plug in hopeful numbers all down the line, and the galaxy comes out crowded, thousands of voices, a busy party. Plug in cautious ones, and the same equation whispers that we might be the only ones talking for a very long way in every direction. The same 7 letters give both answers, depending only on hope. That is the quiet genius of the thing. It does not settle the argument. It shows you exactly where the argument lives. The front of it, the stars and the worlds, has filled in beautifully since that afternoon in West Virginia. The back of it, the part about life and mind and how long anyone lasts, is still mostly hope and humility. The chalkboard did not shrink the mystery. It just drew a tidy box around the part we still cannot reach. It does not mark the treasure. It just shows how much of the ocean is still blank. With the map in hand, the natural thing is to go looking at the nearest promising shores, and some of the most promising ones, it turns out, are surprisingly close to home. The first promising shore is not a planet at all. It is a small moon, far out near Saturn, and it has been quietly leaking its secret into space for longer than there have been people to notice. Its name is Enceladus, which sounds like Enceladus. It is tiny, as these things go. Only about 300 miles across. A person could drive that far between breakfast and supper and think it an easy day. Set beside the Earth, it is a pebble. For a very long time, that is all anyone thought it was. A bright little pebble of ice going around a giant. Then, a spacecraft went to look. It was called Cassini, said Cassini, and it slipped into orbit around Saturn in the summer of 2004. It spent years there, patient and unhurried, sending home photographs of the rings and the many moons. And in 2005, it noticed something strange near the south pole of that small, icy world. Fine jets of frost, rising off the surface and out into space. The little moon was breathing. The jets come from long cracks near the pole, warm seams that the scientists nicknamed the tiger stripes. Out of those seams pour tall fountains of ice and vapor, thrown so high that some of the spray never falls back. It drifts away and helps feed one of the faint outer rings of Saturn, a moon painting a ring with its own breath. It is a very tidy arrangement, and nobody planned it. The obvious question was where the water came from. Ice does not simply leap off a frozen moon for no reason. The answer, worked out over many careful flybys, is the good kind of answer. Underneath the shell of ice, there is a sea, a real one, a global ocean of liquid salt water, wrapped all the way around the moon and hidden beneath its frozen crust. The little pebble is a snow globe with a warm ocean inside. Cassini did something rather bold to learn what that ocean was made of. Instead of landing, which it could not do, it simply flew straight through the plume, more than once. In the autumn of 2015, it made its deepest pass, dropping low and letting the spray wash through its instruments. It tasted the sea of another world without ever touching down. There is something almost comic about it, a billion-dollar machine flying through a moon's exhalation with its mouth open. What it tasted was startling in the gentlest way. Salt, the same kind that is in our own oceans, little grains of it. Then organic molecules, the carbon-built pieces that living chemistry is made from, some of them larger and more complex than anyone expected. And, most telling of all, molecular hydrogen. That last one matters, because on Earth, hydrogen like that seeps up where hot rock meets seawater, at the vents on the deep ocean floor. Its presence hinted that the bottom of the Enceladus Sea is not cold and dead. It may have warm springs, the very kind of place where some scientists think life on Earth first stirred. More recently, in 2023, a fresh look at the old plume data turned up hydrogen cyanide as well, along with other rich organic pieces. Hydrogen cyanide sounds unfriendly, and in a glass of water it certainly would be. Out here, it is something else. It is one of the handy little building blocks that chemists reach for when they try to make the parts of life from scratch. Finding it in the spray of a distant moon is like finding flour and yeast already sitting on the counter. None of this means anyone has found life at Enceladus. It is important to say that plainly. What has been found is a warm, salty, chemically busy sea, sealed under ice, on a small moon most people have never heard of. Water, warmth, and the right ingredients, all in one place, hundreds of millions of miles from the sun. The kitchen is stocked. Whether anything has ever cooked in it, nobody yet knows. A few details make the little moon even harder not to love. Those warm seams at the pole throw their fountains startlingly high, hundreds of miles up, far above the surface, before the ice drifts away. Enough of it escapes that it never comes back down at all. Instead, it spreads out and forms one of the faint, wide rings of Saturn, a whole ring made from the breath of a single small moon. And the snow that does fall back keeps the place gleaming. Enceladus is one of the whitest, most mirror-bright worlds anywhere, because it is forever dusting itself with fresh, clean ice from below. It reflects almost all the light that touches it, a tiny, spotless moon, endlessly repainting its own surface, out where the sun is only a bright star. The obvious puzzle is how something so small stays warm enough for any of this. A pebble that size should have frozen solid to its core ages ago. The answer is the same gravity that raises tides in our own sea, only fiercer. As Enceladus loops around Saturn, the giant's pull stretches and squeezes it over and over. And all that kneading warms the inside like hands working dough. The heat is gentle, but it is steady, and steady is what an ocean needs. There is a kindness in the whole arrangement, too, for anyone hoping to study it. Most worlds keep their secrets locked away. This one hands out free samples. It flings its hidden ocean up into space, unprompted, so that a passing spacecraft can read the chemistry of a buried sea without drilling a single foot of ice. A moon that mails you a letter about itself, over and over, and asks for nothing back. And that is a fine thing to rest on. Somewhere out by Saturn tonight, a little moon is breathing its ocean into the dark. It has been doing it for ages, without an audience, without a fuss. The jets rise and glitter and drift away, and the sea underneath keeps its own slow counsel, whether or not anyone is there to taste it. Enceladus is not the only hidden ocean in our own back garden. There is a larger one, closer to Jupiter, and it may hold more water than every sea on Earth put together. That world is Europa, one of the big moons of Jupiter. It is a little smaller than our own moon, and from a distance, it is one of the smoothest, brightest things in the solar system. A pale marble, wrapped in ice, laced all over with fine reddish lines like the cracks in an old glaze. For a long time, those cracks were a mystery. Now they look like the clearest sign of the sea beneath. Under the ice of Europa, the evidence says, there is an ocean of salty water that never freezes solid and never sees the sky. It may be 60 miles deep in places, far deeper than any ocean here. Add it all up, and Europa, a moon you could tuck inside the Earth many times over, may carry perhaps twice as much liquid water as all of our own oceans combined. The whole thing is kept warm not by sunlight, which is faint that far out, but by the constant squeeze and pull of Jupiter's enormous gravity, kneading the moon like dough and warming it from within. An ocean needs three things to be interesting, and Europa seems to have all three. Water, plainly, warmth from that endless flexing, and chemistry from the rock below and the strange ice above. It is, on paper, one of the most promising places in the solar system to go looking for life that is not us. The difficulty is the lid. The ice on top may be miles thick, and nobody is drilling through miles of ice on a distant moon anytime soon. So the plan is cleverer and more patient. A spacecraft called Europa Clipper left Earth in the autumn of 2024, and it is out there now, crossing the long distance to Jupiter. It is not built to land. It is built to swim past, again and again, dozens of close passes, over the years after it arrives. Around the year 2030, it will map the ice, feel for the ocean underneath, and, where thin plumes may rise, sniff the spray, the same trick Cassini played at Saturn. It is a slow way to explore, and a very human one. We cannot open the box, so we walk around it, tapping, listening, learning its shape by patience. The answers, if they come, will come gently, years from now, long after the launch that most people have already forgotten. The face of Europa tells the story of the sea beneath it. Once a person knows how to read it, those fine reddish lines are cracks, thousands of miles of them, where the ice has split and shifted and healed. In places, the surface looks jumbled, like a frozen harbor where the ice broke into rafts, drifted, and set again. That is exactly what many scientists think happened, driven by the restless water below. The reddish tint in the cracks may be salts, welling up from the ocean and staining the ice, a hint of the chemistry down there written across the surface in faint color. The top of Europa is not a friendly place. Jupiter is wrapped in fierce belts of radiation, and the little moon rides right through them, so its surface is scoured by an invisible sleet that would be quickly fatal to anything living. That sounds grim, but it points the hope downward. Any life at Europa would not be sunbathing on the ice. It would be sheltering far below in the dark water, safe under miles of shield, near the warm rock of the seafloor. And that seafloor is the real prize. Here on Earth, some of the strangest, richest gardens of life crowd around hot vents at the bottom of the ocean, in total blackness, feeding on chemistry instead of sunlight. Whole thriving cities of living things that have never seen the sun. If Europa's sea has vents like those, and the warmth from Jupiter's kneading suggests it might, then the one thing missing is not a place for life. It is simply news of whether life ever moved in. That is what the new visitor is going out to test, patiently, with radar that can peer down into the ice and instruments that can taste any spray it finds. Not a landing, not a drill, just dozens of slow, close passes over years, learning the moon by heart. For tonight, it is enough to know the sea is there. Under the bright, cracked shell of Europa, a dark ocean turns, warmed from below, salted and slow, older than anything that has ever walked on Earth. It keeps its tides in the blackness, unseen and unhurried, and it will still be keeping them long after the lights in this room have gone out. Closer than any of those distant moons, close enough that our own machines have rolled across it, there is a rusty world that has been teasing us for 50 years. Mars. Mars today is cold and dry, a rust-colored desert under a thin pink sky. It was not always so. Billions of years ago, the evidence says, Mars ran with water. Rivers cut channels that are still visible from orbit. Lakes filled the low places. There may even have been a shallow sea across its northern half. For a long stretch of its youth, the red planet was the second promising world in our own system, warmer and wetter, and far more like the young Earth than it is now. We lost it slowly, and the reason is gentle rather than grim. Mars is small. Over ages, it cooled inside, and its protective shield of magnetism faded, and the patient wind from the sun stripped its thick air away a little at a time. The rivers dried. The world went quiet and cold. Not a catastrophe, just a small planet growing old before its larger neighbor did. Naturally, we went to look while the old riverbeds were still there to read. In 1976, two landers named Viking set down on opposite sides of the planet, carrying the first experiments ever built to test another world's soil for life. One of them was especially clever. It fed a pinch of Martian dirt, a little broth laced with a tracer, then waited to see if anything ate the meal and breathed the tracer back out, the way tiny living things do. And something did. On both landers, thousands of miles apart, the soil gave the very signal that, on Earth, would mean something was feeding down there. For one bright moment, it looked like an answer had arrived. Then the doubts crowded in, as good doubts should. A second instrument went looking for the organic molecules that life is built from, and found none in the same soil. That was hard to square. In the end, most scientists decided the feeding signal came not from life, but from some strange, thirsty chemistry in the Martian dust. One of the experiment's own leaders disagreed for the rest of his life and held, quietly and stubbornly, that Viking had found life and been argued out of it. The question has never been fully closed. 2 landers, a repeatable yes, and a 50-year conversation that still is not finished. So we kept returning. A rover named Curiosity, at a different crater, found the bed of an ancient freshwater lake, the kind of calm, drinkable water that could have supported simple life for a very long time, had any been there. And today a newer rover, Perseverance, is at work in a crater called Jezero, said Jezero, chosen with enormous care. Jezero once held a lake, fed by a river that laid down a wide delta of mud and silt. That is exactly the sort of quiet, wet place where the traces of ancient life would gather and keep. The rover is a geologist on wheels, reading those old layers one at a time, and it has crept only a walking afternoon's distance across that crater floor in 5 slow years, because every single turn of the wheels is planned. Not long ago, it found something worth a careful breath. In the delta rock, it came upon odd spots and chemical markings of the sort that, back home, are sometimes left behind by microbes. It might be a faint sign of ancient Martian life. It might be ordinary chemistry wearing a very convincing mask. Nobody is declaring anything. The honest word being used is potential, and it is being weighed slowly and argued over with great care. The rover cannot settle it alone, and it knows its limits, so it is doing something patient and rather touching. It drills small cores from the most promising rock, seals them in clean metal tubes, and sets them gently aside. A couple of dozen of them now wait on the surface of Mars, sealed and labeled, for some future mission to come and carry them home to the laboratories that could finally read them properly. The answer to a 50-year question may already be sitting in a little tube on another planet, waiting for a ride. There is one last small puzzle drifting in the Martian air. Now and then, faint traces of methane rise and fade with the seasons. On Earth, most methane is made by living things. On Mars, it might be life, or it might be slow chemistry between rock and water far underground. It comes, it goes, and it has never been explained. The old red planet keeps a little mystery in its breath. It is worth picturing the place for a moment, because it is stranger and softer than the word desert suggests. The sky over Mars is not blue but a pale, dusty pink, and at sunset, it turns the other way around, glowing faintly blue near the fading sun. Fine rust-colored dust covers everything and hangs in the thin, cold air. Little whirlwinds, dust devils, wander across the empty plains, taller than any on Earth, spinning and then unraveling in the quiet. 2 tiny, lumpy moons cross the sky, far smaller than our own, more like captured stones than proper moons. It is a beautiful, lonely sort of world, and it sits close enough that people have long dreamed of walking there themselves one day. For now, our machines go in our place, slowly, carefully, wearing their tracks into ground that has not felt rain in longer than there have been humans to want it. Every year we learn a little more of how alive, or how empty, that old pink world once was. So Mars holds its answer close, a cold and rusty world that was once young and wet, keeping its maybe folded away in a handful of sealed tubes, as patient now as it has been for a very long time. Now leave the whole family of the sun behind, the moons and the rusty planet alike, and step out to the very nearest star. That star is called Proxima Centauri, said Proxima Centauri, and the word Proxima simply means nearest. It is a small, cool, red star, far dimmer than our sun, the kind that burns low and slow and lasts almost forever. It is the closest star there is, our next-door neighbor in the whole galaxy, and even so, it is preposterously far away. The distance is about 4¼ light years. That is the sort of phrase that slides past the ear, so it is worth slowing down for. It means the light leaving that star tonight will not arrive here until a small child born this evening is halfway through primary school. If somehow a person could drive there on a straight road at highway speed, the trip would take longer than our whole species has existed. This is the nearest thing, the nearest one. And around that nearest star, in 2016, astronomers found a world. They called it Proxima Centauri b. It is a rocky planet, roughly the weight of the Earth, and it sits in the region where a world could, in principle, hold liquid water on its surface. The nearest star to the Sun has an Earth-sized planet in its comfortable zone. Of all the lucky arrangements, that one feels almost staged. It would be lovely to say it is a second Earth, waiting quietly next door. Honesty asks for a little more care. Proxima is a red dwarf, and red dwarfs are moody in their youth and middle age. They throw sudden flares, hard bursts of radiation that could scour the face of a nearby world. Proxima b sits close to its small star, close enough to feel those tempers. It may have kept an atmosphere and an ocean. It may have been stripped bare long ago. From here, for now, nobody can say which. That uncertainty is not a disappointment. It is the honest edge of what we know, and the honest edge is usually the most interesting place to stand. The nearest planet to our own is a real rocky world, in the right place, around the right kind of long-lived star. It might be a ruin, it might be a garden. It is close enough that someday someone patient may find out. Proxima has company, which makes the whole corner of sky more interesting. It is the small, faint, outermost member of a set of 3 stars huddled together, the nearest little family to our own. 2 of them are bright and rather sun-like, a close pair. Proxima drifts far out around them, dim and red and patient, and by a happy accident of its orbit it is, just now, the closest single star to us of the 3. The world around it was teased out by watching that star sway. A careful team spent a season tracking Proxima's tiny rocking back and forth, a project with the lovely name Pale Red Dot, and out of the wobble, a planet appeared. It gives off no light of its own that we can see. It was found entirely by the gentle tug it gives its star, a whole world weighed by its pull on a distant point of red light. If a person could stand on it, the view would be strange and beautiful. Proxima b likely keeps one face turned always toward its star, the way the moon keeps one face toward the Earth. That would mean a side of endless daylight and a side of endless night, and between them a band of everlasting evening, a ring of soft twilight running pole to pole. If the world is mild anywhere, it might be mild there, in that circle of permanent dusk. People have even dreamed, out loud and seriously, about going. One idea imagines tiny feather-like probes, each smaller than a hand, pushed up to a fair fraction of the speed of light by a great bank of lasers, coasting for a few decades and then flying past to send home a single postcard. It is only a dream for now, and even in the dream, the trip takes lifetimes. The nearest star is close enough to point at, and still far enough to humble anyone who reaches toward it. Until then, it simply circles, once every 11 days or so, around its small red sun. The nearest door in all the universe stays shut, a little over 4 years of light away, and it is in no particular hurry to open. One star is a single door. Now and then, though, a star turns out to have a whole hallway of them. In the winter of 2017, a team of astronomers shared a picture that stopped a lot of people mid-sentence. Around a small, dim, ultra-cool red star, they had found 7 worlds. 7. All of them close in size to the Earth, all of them rocky, all circling one little sun in tight, quick loops. The star is called TRAPPIST-1, said TRAPPIST, and its family of 7 is still one of the neatest surprises in the whole search. The name has a pleasant story behind it. The worlds were first spotted by a modest telescope in Chile, and that telescope was named, with a wink, after the Trappist monks, who are famous for brewing very good and very patient beer. So the grandest set of Earth-sized worlds yet found around another star was discovered by an instrument named for quiet brewing. Astronomers have a sense of humor, even if they keep it dry. The system sits about 40 light-years away, in the direction of a faint constellation. 40 years of light is close, by the standards of this story, and impossibly far by any other. The light arriving from that little red star tonight set out around the time the first home computers were appearing. It has been traveling the whole while, just to show us 7 distant worlds. And what worlds? They orbit so close to their small, cool star, and so close to one another, that the whole system would fit neatly inside the orbit of our own innermost planet. Their years are only days long. From the surface of one, the others would not be distant points of light. They would hang in the sky as real disks, banded and colored, close enough to watch turning. A person standing on one of those worlds could look up and see the neighbors as clearly as we see the moon. The best part for this story is where they sit. Of the 7, 3 ride in the temperate band around the star, the region where a rocky world could hold liquid water if the rest of the luck fell its way. 3 chances at once, around a single small sun. No other known system offers quite so many temperate, Earth-sized worlds in one place. Of course, luck has to fall a long way. These worlds probably keep one side forever, toward their star, locked in place, so each would have an endless day on one half and an endless night on the other. Their red sun, like Proxima, may have been fierce in its youth, and the newest telescopes, now turning to read the air of each world in turn, have brought back careful, mixed, honest results. Some of the inner worlds look to have little or no atmosphere at all. The temperate ones are harder to read, and the work goes slowly, as good work does. Still, the plain fact of the place is a small marvel. 7 Earth-sized worlds around one star, a crowded little system, 40 years of light away, that nobody even suspected a decade ago. If a person wanted a reason to think the galaxy might be generous with worlds, TRAPPIST-1 is a good one to keep in a pocket. A few things about that star and its worlds make the picture even warmer. The star itself is barely a star at all by our standards. It is an ultra-cool dwarf, only a little larger than the planet Jupiter, dim and red and cool by stellar standards. The kind of ember that will go on burning steadily for trillions of years, long after suns like ours have guttered out. Slow and faint and patient, it may be one of the longest-lived hearths in the whole galaxy. The 7 worlds keep a rhythm that astronomers find almost musical. Their orbits are locked into a gentle chain, each one tugging the next, so that they circle in a steady, repeating pattern, like a set of gears that agreed long ago to keep time together. Systems like that are delicate and rare, and this one has apparently held its beat for billions of years. The finding came in stages, which is part of its charm. That small telescope in Chile first caught sight of only a few of the worlds, a hint that something was there. Then a space telescope stared at the little star for weeks on end, unblinking, and watched the shadows cross, one by one, until all 7 had shown themselves. Patience again, always patience. The universe rarely shows its hand all at once. Since then, the finest telescope ever flown has begun to study the air of these worlds, one at a time. The results so far are careful and honest, and not all hopeful. The innermost worlds, closest to the little star, look to have thin atmospheres or none at all. The temperate ones, further out, give murkier answers, and their study is slow and unfinished. Nobody is promising anything. They are simply looking patiently and telling the truth about what they find. For now, the 7 of them simply go around and around their small red star in a tight, ancient dance, throwing their light across 40 years of empty space to a few quiet astronomers who find them lovely. It is worth stopping here to ask a slower question. What does a world actually need to have a chance at life at all? The first thing everyone names is water in its liquid form. Not ice, not steam, but liquid. The kind that pools and flows and dissolves things and lets chemistry mix. That is why the search keeps circling back to warmth and to seas. Around every star there is a band, not too hot and not too cold, where a rocky world could keep liquid water on its surface. Somebody, long ago, started calling it the Goldilocks zone, because it has to be just right, and the name stuck the way good silly names do. Water is not the whole recipe, though. Life as we understand it also wants carbon, the friendly element that links up into long, complicated chains. It wants a steady supply of energy, whether from a sun overhead or a warm vent below. And more than anything, it seems to want time. Great, unhurried stretches of it. Here the Earth offers one clue, and it is a hopeful one. Our planet formed about 4.5 billion years ago, in fire and bombardment, and life appears to have shown up almost as soon as the place cooled enough to allow it. The oldest traces reach back 3.5 billion years, maybe more. In other words, life did not dawdle. Give the young Earth an ocean and a little while, and something living seems to have started up quite promptly, as if it had been waiting for the door to open. That promptness makes some scientists hopeful that life, the simple kind, might be easy, common even, and there is more comfort in the same direction. Life here turned out to be astonishingly tough. It thrives in boiling water and freezing rock, in acid, in places with no sunlight at all, miles below the ground. Whatever life is, it clings on hard, and it fills every corner it can reach. But honesty asks for the other half of the story, and the other half is humbling. We have exactly one example of life anywhere. One, just the Earth. From a single example, nobody can really tell whether life is a thing that happens easily wherever it can, or a one-time fluke so rare it may not have happened twice in the whole visible universe. One data point draws a very lonely graph, and there is a second puzzle hiding inside the first. Simple life may have come quickly, but complicated life took its sweet time. For most of Earth's long history, the most advanced thing alive was a film of tiny cells, pond scum, essentially, and it ran the whole planet by itself for billions of years. It was very good at it. The jump from those simple cells to anything larger and more clever took nearly the entire age of the Earth, which raises a quiet possibility. Maybe life is common, and minds are the rare thing. So the recipe is part known, part guessed. Water, warmth, carbon, energy, time. We can see where the ingredients might gather. What we cannot yet see is how often the meal actually gets made, or how often, once made, it ever sits up and starts to wonder about itself. The comfortable zone around a star is not fixed, which is worth knowing. Around a hot, bright star, it sits far out, where the warmth thins to just right. Around a small, cool ember, like the ones we keep meeting, it huddles in close, almost against the star. So the warm band moves, but there is one around nearly every sun, a lane where water could stay liquid if the rest of the luck held. A world also needs a blanket, an atmosphere, to hold that warmth and steady it. Too thin a blanket, and the heat leaks away into space, the way it has on cold, dry Mars. Too thick, and it smothers, the way it has on Venus, where the air itself has turned the whole planet into a furnace. Somewhere between those two, on a world with just enough air, water can pool and stay. The margins are finer than they first appear. There is a deeper humility hiding under all of this, and it is a healthy one. Everything we call life is built from carbon and runs on water, because that is the only kind we have ever met. We may simply be looking for copies of ourselves and missing stranger things, that do not play by our rules. When a scientist draws the comfortable zone, they are really drawing the zone comfortable for us. And yet life, at least our kind, is far tougher than that caution suggests. It turns up in scalding water and in ice that never melts. It lives in acid, in rock, miles underground, around the boiling vents of the deep sea where no light has ever reached. There is a small creature, barely visible, that can dry out completely, be frozen, be flung into the vacuum of space, and simply wake up again later, unbothered. Once life gets a grip, it is astonishingly hard to shake loose. The other side of the ledger is a sobering thought some scientists take seriously. Maybe the Earth is not ordinary at all. Maybe it took a rare run of luck to build a place this steady, a large moon to calm its spin, a slow churn of continents to keep the chemistry fresh, a giant planet out beyond it to sweep away some of the wandering debris. If that is right, then simple life might be common, while comfortable, stable worlds like ours are the true rarity. So the picture stays balanced, and honestly so. Life may be easy and everywhere, or the Earth may be a quiet stroke of fortune. Both can be true of a universe this size, and tonight there is no need to choose between them. There is a wrinkle in the Earth's own story worth sitting with, because it may be the whole answer. Simple life came quickly here, and then stalled for an extraordinary span of time. For billions of years, the living world stayed small and simple, single cells and little more, content and unhurried. The leap from those plain cells to the larger, more intricate kind, the sort that can build bodies and, eventually, brains, appears to have happened only once in all that long while, and only after an enormous wait. Every tree, every whale, every person seems to trace back to that single, unlikely turn. If that is how it usually goes, then the picture shifts in a curious way. The galaxy could be damp with simple life and nearly empty of the complicated kind. Warm little seas everywhere, full of patient slime, and only very rarely anything that sits up and looks around. That would be a strange sort of comfort. Not alone in having life, only alone, or nearly so, in wondering about it. Or perhaps that long pause was ordinary, and we arrived at a perfectly normal hour. From one example, there is simply no way to tell. The single world we can read closely says that life begins easily and grows complicated with great reluctance. And it will not say whether that is the rule across the sky or only the tale of one small planet. The one example we have keeps that secret close. It will not tell us whether it was an easy thing or a small miracle. And so, for now, we simply hold both thoughts at once, gently, and keep looking. So far, the search has been about places, about seas and stars and temperate zones. Now it turns to listening, and listening has its own strange evening, one that happened on the 15th of August, 1977. There was a radio telescope in Ohio, a big flat one with the affectionate nickname Big Ear. Its job was patient and dull in the best way. It swept slowly across the sky, night after night, listening on the quiet radio channels for anything that sounded too clean, too narrow, too deliberate to be natural. Then it printed what it heard as columns of numbers and letters on long sheets of paper, and people read the sheets by hand, later over coffee. A few days after that August night, a volunteer named Jerry Eman, said AY Man, was working through a stack of those printouts. Most of it was the usual gentle noise of the universe. Then his eye caught a column that did not belong. A signal had risen up, held strong for about 72 seconds, and faded away. It was roughly 30 times louder than the empty sky around it. It came from the direction of the constellation Sagittarius, and it sat right near the frequency that hydrogen, the commonest stuff in the universe, quietly hums at, around 1420 megahertz. That frequency is a clever place to look, which is what made it exciting. If a person wanted to be heard across the galaxy, they might call on the one channel everyone everywhere can tune to, the natural note of the most common element there is. The signal was strong, narrow, and it rose and fell exactly as a fixed point in the sky should, as the Earth turned beneath the telescope. It did not look like a passing plane or a stray spark from the ground. It looked, for all the world, like someone calling. Eman circled the numbers in red ballpoint. Beside them, in the margin, he wrote a single word: wow. And so the strongest, strangest thing that patient telescope ever heard has been known, ever since, as the wow signal. The most famous message from the sky, and the label on it is a human being's startled exclamation in pen. Then came the hard part, the part that makes it a real story rather than a tidy one. The telescope looked again, that night and for years after. Other telescopes looked too. Nobody has ever heard it a second time. It came once, held for a little over a minute, and never returned. Worse, no one saved a recording of the actual sound. Only the log of its loudness survives, those few circled characters on aging paper. For decades it has sat there, unexplained and irresistible. In recent years, some careful scientists, poring back over old data, have offered a natural answer. A cloud of cold hydrogen out in space, they suggest, might have been briefly lit up, brightened for a moment by some passing burst of energy, and that flash could look a lot like the wow signal. It is a reasonable idea. It may well be right. It is not yet certain, and honest people still call the signal unexplained. That is the whole shape of it, and it is a very human shape. One strong, clean note from the direction of the galaxy's heart. 72 seconds, one time, in more than 50 years of listening. It is probably nothing. It might be something. Nobody has to decide tonight. The machine itself is part of why the signal still fascinates. Big Ear had no great swiveling dish. It was a long, flat instrument that lay still and let the sky drift over it as the Earth turned. Anything real, fixed among the stars, would slide slowly through its view and take about 72 seconds to cross. So a genuine signal from space would rise, peak, and fade over roughly that span. The wow signal rose, peaked, and faded over exactly that span. It carried the fingerprint of the sky, not the clumsy mark of something nearby on the ground. Even the odd little code beside it, those circled characters, was just a way of writing down loudness. Quiet moments got low numbers. Louder ones climbed toward higher numbers. And then, when a sound was louder than any single digit could hold, the log rolled over into letters. A letter meant very loud indeed. The signal reached deep into the letters, far above the gentle hiss around it. That is what made a tired volunteer sit up and reach for a red pen. Why nobody ever caught it again is part of the ache. It was not noticed live. By the time human eyes found it in the printout, days later, the moment had long passed, and a thing that comes only once can never quite be proven. The same patch of sky has been checked many times since, by better ears than big ear. It has stayed silent every time. People have tried hard to explain it away, which is exactly what people should do. One idea blamed a pair of passing comets, though comets do not usually shine like that. A newer idea suggests a cloud of cold hydrogen out in space, briefly lit up by some burst of energy passing through. That may well be the answer. It has not been nailed down, and honest scientists still file the wow signal under unexplained, with a small shrug and a fond smile. The searching did not end with that one night. Over the years that followed, larger and sharper instruments were turned toward the same patch of Sagittarius, again and again, by people who badly wanted to catch it a second time. They listened with far finer ears than the one that first heard it. Each time they found the ordinary hiss of the sky and nothing more. A signal that will not repeat, can never be studied, and never be confirmed, however much anyone wishes otherwise. That is the gentle frustration at the center of the story. The signal did everything a hopeful one should. It arrived on the sensible frequency, narrow and strong, from out among the stars, rising and falling just as a true source would. It looked exactly like the thing the listeners had been waiting for. And then it simply never came again, and left nothing behind to test. Hope and proof are different things, and this one has always lived in the gap between them. That mix is the whole charm of it. Enough romance to keep the story alive for 50 years. Enough discipline that nobody sensible has ever claimed it was a message. A strong, clean note, once, from the direction of the galaxy's crowded heart, and then nothing. And the single word in the margin has outlived the machine that printed the numbers, still sitting there in red ink, saying only, quietly, wow. For all the talk of distant seas, the search has mostly been carried out by people sitting quietly in rooms, wearing headphones, listening to the sky. It began in earnest in the spring of 1960. A young astronomer, the same Frank Drake who would later stand at that chalkboard, pointed a radio dish in West Virginia at two nearby sun-like stars. Their names are Tau Ceti, said Tau Ct, and Epsilon Eridani, said Epsish Lon Eridani, each about 11 light years off. He tuned his receiver to the hydrogen frequency, the natural note, and he listened for anything that sounded made rather than born. He called the effort Project Ozma, after the Queen of the Land of Oz. A place, as he put it, far away and full of strange and exotic beings. It is a charming name for the first serious attempt to overhear the neighbors. For weeks, the dish listened, several hours a day. There was one flurry of excitement, a strong, clean signal early on, which turned out to be a passing aircraft. After that, only static. The soft, even hiss of a universe that was not, as far as anyone could tell, trying to say anything. That could have been the end of it. Instead, it was the beginning of a long and stubborn tradition. Off and on, for more than 60 years since, people have kept listening. The tools have grown enormous. In 2015, a wealthy backer named Yuri Milner put $100 million behind a 10-year effort called Breakthrough Listen, aimed at 1 million of the nearest stars and the hearts of 100 galaxies. The announcement went out on the anniversary of the first moon landing, and the physicist Stephen Hawking lent it his name. All of the data it gathers is shared freely for anyone to sift. The great dishes that do this work have their own quiet drama. For more than half a century, the largest was a vast bowl set into a valley in Puerto Rico, 1,000 feet across, called Arecibo. Said Arecibo. It listened to the sky for generations. Then, in December of 2020, after its cables had begun to fail, its heavy instrument platform tore loose and crashed into the dish below. The great ear went silent for good. Many astronomers wept, a little, for a machine. The largest single dish now sits in a natural bowl among the hills of southern China. It is 500 meters across, wide enough to hold many football fields, and its builders gave it a lovely name. They call it Tianyan, the eye of the sky. It stares upward, still and enormous, sweeping the same quiet channels the little dish in West Virginia swept all those years ago. There is something moving in all of this patience. A person who began listening as a young graduate in 1960 could have spent an entire working life at it, an entire career of careful attention, and heard nothing certain at all. And a great many people did exactly that, gladly. They were not disappointed, most of them. They understood that a real search is mostly waiting, and that a quiet sky is still an answer, of a kind. The story of the listening has its own gentle ups and downs, and they are rather endearing. For a while, the effort had government money behind it. Then, in the early 1990s, the funding was cut, mocked as a waste by people who wanted a tidier budget. The search did not die. It simply moved to private hands. A dedicated institute took it up, and later a generous backer paid for a whole field of small dishes that could listen together, spread across a high desert valley, all pointed at the same quiet questions. The listeners even have a favorite place to tune, and its name is lovely. Between the natural note of hydrogen and the natural note of a related molecule lies a calm, quiet stretch of the radio spectrum. Because those two ingredients together make water, someone long ago called that band the water hole, and suggested it might be where different peoples would naturally gather to call out, the way animals once met at the watering place. It is a soft and hopeful idea that the whole galaxy might agree, without ever speaking, on where to meet. The false alarms along the way have been charming more often than not. For years, one observatory kept catching strange bursts of radio that seemed to come from the sky. They puzzled over them for a long time. In the end, the culprit turned out to be the staff microwave oven down the hall, opened a few seconds early by someone impatient for lunch. The universe, it turned out, was quiet, and the kitchen was not. Scientists tell that story on themselves with great affection. Under all the equipment and the funding fights and the microwave ovens, there is that steadiness again. A person who began this work as a young graduate could listen for a lifetime and hear nothing certain. A great many did exactly that, and counted it time well spent. They learned the rare and useful art of being content with an open question. So the dishes go on turning toward the silence, night after night, listening for a voice that has not yet come. They are tended by people who have made their peace with maybe. And that patience is its own soft comfort, whether or not the sky ever answers back. Listening is only half of a conversation. Once or twice, quietly, we have also tried to speak. In 1974, for a few minutes, the great dish at Arecibo turned from listening to talking. It sent out a single strong pulse of radio, aimed at a distant huddle of stars, a great globular cluster called Messier 13. The message was simple and hopeful, and a little charming. Coded in ones and zeros were the numbers we count with, the makeup of the chemistry in our bodies, a small stick figure of a human being, a sketch of our solar system with the third world marked as home, and a picture of the very dish doing the sending. It was more a gesture than a real letter. That cluster of stars is so far away that the message will not arrive for something like 25,000 years. And by then, the stars will have drifted from where we aimed. Everyone involved knew this. They sent it anyway, the way a person might write a note and seal it in a bottle, not really expecting a reply, just wanting to have said hello. Even before that broadcast, we had sent something a hand could hold. In the early 1970s, two small craft named Pioneer set off to pass the giant planets and then keep going, out of the solar system for good. Someone had the quiet foresight to bolt a small gold-colored plaque to each one. Etched into the metal were two human figures, a simple map pointing the way back to our sun, and a mark standing for hydrogen, the common thread running through everything. There was some fuss, even then, about which picture of ourselves to send, and the artists did their best under the weight of speaking for a whole planet on a single small plate. They were the first messages from Earth ever aimed past the planets, scratched into metal rather than shouted in radio, built to ride quietly into the dark for as long as metal can last. Two little calling cards, sent out by people who simply did not want their species to slip out of the solar system without leaving a note. Both plaques are out there still, sailing in different directions, unread. 3 years later came the tenderer gesture, and it is still traveling. When the two Voyager spacecraft left Earth in 1977, each carried a golden record, an actual phonograph record, plated in gold, with a needle tucked beside it, and simple picture instructions for how to play it. A committee, led by Carl Sagan, had chosen what to put on it, and the choosing was a small, human, argued-over thing. On the record are 116 images of life on Earth. There are sounds, wind and rain and surf, a heartbeat, a kiss, a mother speaking to a child. There are greetings spoken in 55 languages, warm and formal and shy by turns. And there is music, an hour and a half of it, gathered from all over the world, because someone felt that whoever found it ought to hear what we sounded like when we sang. The Voyagers have long since finished their tour of the planets. Both are now beyond the heliosphere, operating in interstellar space, the farthest things human hands have ever made. Neither is aimed at any particular star. They are simply drifting, very slowly, into the great open dark, each with its golden record bolted on, in case. The choosing of what went on the record is a small, human story all by itself. They gathered the sounds of a whole world, surf and wind and rain, a heartbeat, footsteps and laughter, the cry of a newborn baby, and a mother's soft voice answering. They put on the song of whales, in case music is a thing shared even with our fellow creatures here at home. And then the music of people, an hour and a half of it, from the careful order of Bach to the rough joy of early rock and roll, chosen after long, fond arguments about which of all our songs should stand for us. The cover of the record was made to be a puzzle a stranger could solve. Etched on it is a map, not of places but of certain rare spinning stars, arranged so that anyone clever enough could trace the lines back and find the sun. There is a simple diagram of hydrogen, the commonest thing there is, offered as a universal clock and ruler. It is a message that assumes nothing except patience and curiosity, the two things the makers most hoped a finder would share. There is one detail on that record so tender it is hard to say plainly. Among the sounds is a recording of a young woman's body and mind, her heartbeat and her brain waves, gathered while she sat and thought, on purpose, about someone she had just fallen in love with. That someone was the man leading the whole project. The two of them married not long after. So pressed into those grooves, sailing forever between the stars, is the quiet electrical trace of a human being in the first days of love. Of all the things to send into the dark, they sent that. The lovely, aching part is the arithmetic of it. Out there, away from weather and rust, those records could last for more than 1 billion years, far longer than any human civilization has yet endured. 2 little gold discs may still be sailing between the stars, carrying a mother's voice and a few bars of music, and 55 ways of saying hello, perfectly preserved, unheard. And so the small gold record sails on into the dark, singing to no one in particular, keeping its greetings safe and bright for a very long time to come. Listening for a message is only one way to search. There is another, and it waits for no one to call. It looks instead for the marks a busy civilization might not be able to hide. The idea began with a physicist named Freeman Dyson back in 1960. He noticed something simple about growing up. As a species, A civilization that keeps expanding, keeps needing more energy, more than a single planet can supply. And the richest source of energy anywhere near a world is the star it circles, pouring out its light in every direction, almost all of it streaming off into empty space, unused. Dyson wondered what a very old, very patient people might do about all that waste. His answer was that they might, over ages, build to catch it. Not a solid shell wrapped around the star, which is the cartoon version and would not hold together. Something looser, a vast swarm of countless collectors, drifting in their own orbits, gradually surrounding the star and drinking its light. A sun slowly wrapped in a harvest of its own making. People have called such a thing a Dyson sphere ever since, and it remains one of the grander things a civilization might, in principle, build. The clever part, for a searcher, is that a structure like that could not stay secret. Energy cannot simply be used and vanish. Whatever caught the star's light would warm up, and give that warmth back off as heat, glowing softly in the infrared, the part of the spectrum we feel rather than see. So a wrapped star would look wrong in a very particular way. It would seem dimmer than it should in ordinary light, and too warm in the infrared. And that is something a telescope could notice from very far away, without anyone ever sending a signal at all. So astronomers have looked. They have combed through great catalogs of stars, and even whole galaxies, hunting for that odd double fingerprint, too little light and too much heat. It is a patient, sifting sort of search. So far, nothing has turned up that needs a civilization to explain it. The warmth found always has a plainer cause. There was one star that set hearts racing for a while. It sits about 1,500 light years away, and it is best known by an affectionate nickname, Tabby's star, after the astronomer who studied it. In 2015, careful eyes noticed it doing something no ordinary star should. It dimmed, deeply and strangely, sometimes by nearly a fifth of its light, in ragged dips that lasted days and followed no tidy schedule. A planet crossing a star makes a small, neat, regular shadow. This was nothing like that. It was big and messy and unpredictable. For a season, some serious people wondered aloud whether we might be watching a great structure being built, a half-finished swarm passing in front of its sun. The idea leapt into every headline. It was, briefly, the most exciting star in the sky. Then the searchers did the patient thing and watched exactly how the star dimmed, color by color. A solid object blocks every color of light equally. Fine dust does not. Dust dims blue light more than red and leaves a telltale reddish cast. The dimming of Tabby's star carried that reddish cast. The most likely answer, worked out over the following years, is not a structure at all. It is an uneven cloud of ordinary dust, drifting around the star, thinning and thickening as it orbits. Not engineering, dust. That could feel like a letdown, and it is worth noticing that it is not. This is the search working exactly as it should. We saw something we could not explain. We let ourselves wonder, out loud, without shame. Then we checked, carefully, and the universe handed back a quieter answer, and we accepted it. Every marvel ruled out, is not a door slammed. It is the search learning to see more clearly. The wondering was never the mistake. The wondering is the whole point. The larger hunt goes on quietly, and it is a strange and lovely thing to attempt. Searchers have combed through the records of many thousands of stars, and even swept their gaze across whole distant galaxies, looking for that telltale sign of warmth without light. If some far people had wrapped their star, or lit a whole galaxy with their industry, there might be a patch of sky that shines wrong, too much heat and too little light to be natural. No such patch has turned up. Every warm glow examined so far has had an ordinary cause: dust and gas, and the slow business of stars being made. That is not a failure either. It quietly tells us something real and rather steadying. Whatever else may be out there, the galaxy is not obviously carved up and put to work by anyone. No nearby star wears a visible cage. The lights we can see are, as far as anyone can tell, simply stars, burning for no one's purpose but their own. A sky full of wild, unclaimed fire is its own kind of answer, and not a lonely one. So the star goes on flickering behind its thin veil of dust, keeping its own counsel, and the searchers move on through the catalog, no less curious for having been gently wrong. Every so often, with no warning at all, something from another star comes to us instead. For all of history, everything in our sky belonged to our own sun. Then, in the autumn of 2017, astronomers caught something that did not. A small object, tumbling, moving far too fast to be one of ours, on a path that could only have come from another star. It was the first visitor from beyond ever caught in the act. They gave it a Hawaiian name, Oumuamua, said Oumuamua, which means something like a scout or one who reaches out from far away. Oumuamua was strange. It was oddly long and thin. It showed no proper comet's tail, and it sped up a little as it left, in a way that took some explaining. A few people wondered aloud, briefly and loudly, whether it might be a piece of alien technology. Most astronomers, looking carefully, concluded it was natural, an odd shard of ice or rock from some distant system, behaving in unusual but explainable ways. It was gone before anyone could get a close look, back out into the dark, never to return. 2 years later, a second visitor arrived, and this one was plainly a comet, an ordinary icy wanderer that happened to be born around another star. And then, in the summer of 2025, only about a year ago now, came a third. It was found on the 1st of July by a survey telescope and named for that survey. It appears to be a comet as well, and a very old one, likely flung out of the thick, ancient part of our galaxy billions of years before the sun was born. An old traveler, passing through on its way to somewhere else. Each of the three had a character of its own, and astronomers came to know them a little, the way a town comes to know the travelers passing through it. The first, Oumuamua, was the strangest. As it turned, its brightness swung up and down every few hours, which meant it was oddly long and thin, a dark reddish splinter unlike anything in our own system. It wore no comet's tail and on its way back out, it sped up by a shade more than the sun's pull alone could account for. That small extra nudge began a lively argument. One well-known scientist proposed, loudly and in public, that it might be a piece of alien craft, a thin sail catching starlight. Most of his colleagues, weighing what little there was to weigh, judged it natural, an unusual shard behaving in unusual but explainable ways. The real trouble was time. We simply had not caught it early enough to study it before it was gone. The second visitor was almost a relief. It was plainly a comet, a fuzzy traveler with a proper tail, doing just what comets do, only born around some other star. It had even been first spotted by an amateur, a man watching the sky with his own telescope from his own backyard. Ordinary, in the most reassuring way, a reminder that most wanderers are only ice and rock. The third, the one from last summer, may be the oldest thing ever to pass our way. Its path traces back to the thick, ancient part of the galaxy, and its makeup hints that it is older than the sun itself, a relic from before the Earth had formed. This time we were not caught flat-footed. Several spacecraft already scattered across the solar system turned to watch it drift by, catching it from angles no telescope at home could manage. For once, a traveler from another star arrived to find us waiting, quietly, with the instruments already pointed. Here is the part worth keeping. When that third visitor came through, some of the very telescopes we have been talking about turned to face it and listened. They pointed at this lump of ancient ice and swept it for any hint of an artificial signal, any whisper of a machine. It was a reasonable thing to check. A visitor from another star is exactly the sort of thing worth pointing an ear at. And they heard nothing unusual at all, just a natural comet, quietly shedding gas and dust as the sun warmed it, exactly as a comet should. That small episode is the whole spirit of this search in miniature. We noticed the stranger, we stayed calm, we checked, politely and carefully, and when the answer came back ordinary, that was fine, genuinely fine, not a letdown. The same care shows up elsewhere. Not long ago, a distant world caught everyone's attention when a great telescope seemed to sniff, in its air, a gas that on Earth is made only by living things. There was a flutter of hope. Then other scientists re-examined the same light, again and again, and found the sign too faint to trust. The hope quietly faded, and the careful ones nodded, because that checking is the point. This is what honest looking feels like. It is not a string of shocks and revelations. It is noticing and staying steady and checking your own excitement and being willing to say, most of the time, we are not sure, or it was nothing after all. That patience is not the failure of the search. It is the best thing about it. So the old traveler slipped back out toward the stars it came from, carrying its long silence with it, exactly as a well-behaved comet should, and the telescopes turned, unhurried, back to the rest of the sky. So, after all of that, we come back to the man and the question at the lunch table. Where is everybody? There is no single answer, but there are several honest ones, and it is worth laying them out side by side, because most of them are far gentler than they first appear. The first possibility is simply that life is rare. Perhaps the step from lifeless chemistry to the first living thing is so unlikely that it almost never happens. And we are one of the very few places, maybe the only place nearby, where it did. That would make the Earth precious beyond measure. Lonely, yes, but precious. The second is kinder to life and harder on minds. Perhaps simple living things are everywhere, filling warm seas under 1,000 sheets of ice. And the rare step is the one that leads to curiosity. Remember that on Earth, the pond scum ran the show for billions of years. Maybe the galaxy is damp with simple life and nearly empty of anyone wondering about it. The third needs no rare miracle at all. Perhaps they are out there, and the trouble is only distance and timing. The galaxy is so wide that a signal grows faint and slips beneath the noise long before it reaches us. Two civilizations would have to be listening in the same brief window, across an ocean of time, and simply miss each other, like two people waving from opposite ends of a very long, dark beach. That third idea leads to the gentlest thought of the night, which is about time. The universe is about 14 billion years old. Our kind has been able to listen to the sky for around 60 years, and to send radio at all for barely a century. Set one human lifetime of listening against the whole long age of the galaxy, and it is less than a blink. We have had our ears open for a single moment at the very start of a very long evening, and the evening has hardly begun. Stars will keep being born for 1 trillion years yet. On that scale, we are not late to a party that has ended. We are early. We may be among the first to arrive, standing in a quiet room, wondering why no one else is here, when the truth is that most of the guests have not been born. There are other gentle answers too, and they cost nothing to hold. Perhaps they are out there and simply not shouting. Loud radio may be a brief phase for any people, a noisy century or two before they settle into quieter, tidier ways of talking among themselves, ways we could never overhear from here. If so, the galaxy could be full of conversation, all of it as private as a murmur in the next room. Perhaps the distances are just too great to bother with. To cross the gulf between stars, or even to call across it loudly enough to be heard, may cost far more than most civilizations ever find worth spending. It could be that nearly everyone stays home, tending their own worlds, for the same sensible reasons we have not yet left ours. Not hiding, only busy and far apart, and content where they are. Or perhaps they have noticed us and thought little of it, the way a person on a walk notices an anthill without stopping to knock. A young world, only lately able to make radio at all, may simply not be interesting yet. There is no unkindness in that idea. A quiet neighborhood is not the same as an empty one. There is one more idea, and it has a small shadow in it, so we will name it plainly and then set it down. Some thinkers speak of a great filter, a name given in the late 1990s to whatever it is that keeps the galaxy so quiet. Maybe that filter is behind us, one of those unlikely steps we somehow already passed, which would mean we are rare and very lucky. Or maybe, some worry, it lies ahead, and civilizations tend not to last. That second version is the darker one. But notice that nobody knows it is true, and the quiet sky is explained just as well by distance, or by youth, or by life being uncommon. A shadow is not a verdict. We can let that one go. Because when the honest possibilities are all laid out, the frightening one is only a single option among many, and nobody yet knows how to rank them. The silence could mean the neighbors are too far, too long ago, too recent, too quiet, or simply that we have barely begun to listen. And that last part is plainly true. All the searching done so far, across all those years and all those dishes, adds up to something astonishingly small. It is a little like dipping one drinking glass into all the oceans of the earth, finding no fish in the glass, and setting it down. The glass tells you almost nothing about the sea. So the great silence, held up to the light, turns out to be mostly a silence of our own beginnings. Not a locked and empty house, a vast one, barely explored, with most of its rooms still dark, on an evening that has only just started. We looked in one glass of water. The ocean is still out there, and we have hardly gotten wet. That is a good place to stop looking, and to let the night settle. We went a long way tonight, without leaving the bed. We stood at the edge of a lunch table in the desert and heard a man wonder where everyone was. We tried to count the suns and gave up, gladly, somewhere in the billions. We watched a small moon breathe its ocean into space and imagined the dark sea turning under the ice of another. We stood at the nearest door, 4 years of light away, and found it closed. We saw 7 worlds circle one small red star. We heard a single strong note arrive from the heart of the galaxy and never come again. We sat with the patient people at their great dishes and watched a little gold record sail off into forever, singing to no one. And here is the one thought worth carrying down into sleep. Whether the universe turns out to be crowded or nearly empty, the plain fact that one small, wet corner of it woke up and looked around and cared enough to ask whether it was alone is a quiet miracle all by itself. And tonight, that corner is right here, warm and safe and wondering. It is all still out there now, very far away and in no hurry. The moons are still breathing. The dishes are still turning. The gold record is still singing to the dark. And the third visitor is still drifting back into interstellar space. None of it needs anything from anyone tonight. It will all keep patiently while the world turns quietly under the window. So rest now. There is nowhere to be and no one to answer, and nothing left to find before morning. Let the sky be quiet. Let it be enough. Sleep for as long as it lasts. Good night.